Hi everyone, welcome back to my channel. Today I'll be going over acetal formation. This is a common reaction that you'll see in the carbonyl unit, so stay tuned. So when doing acetal formation, you're going to have a molecule with a carbonyl containing portion of it. The parent chain could be different, but as long as it has a carbonyl group and the correct reagents, you can do this reaction. The reagents are going to be methanol, H3O+, and H2O. Our final product is then going to contain that same parent chain with two alkoxide groups attached to it. A lot of professors like to use this acronym called PADPED. Me personally, I don't like it only because it takes away from actually learning the chemistry. I feel like by learning this acronym, you're just taking it one step at a time, kind of like a robot, and you don't really know the chemistry going on. But once again, that's different from person to person, and you're more than welcome to use it. What PADPED stands for is protonation, addition, deprotonation, protonation once again, elimination, another addition, and deprotonation. However, the bottom line is, if you know where we're beginning and what the end molecule looks like, it shouldn't really be an issue, and you don't really have to use the PADPED acronym. So in that case, I'm just going to delete it right now. One thing you have to know is that for most carbonyl containing, so like aldehyde and ketone containing groups, you want to usually protonate it. That's going to be done usually in the first step, but it could also be done later on. In our case, we're going to do that as the first step. So we're going to redraw our starting molecule. And let's take a look at our reagents real quick. What has the capability to protonate? We could protonate it with methanol or H3O+. I'm going to use the H3O+. So we're going to have our H3O+, which I'm going to draw right here. The oxygen of the carbonyl is going to go and abstract this hydrogen, which then will look like this. And then from there, we're going to have a positive formal charge on that oxygen, and we're going to create water on the side. I'm not going to really explain the formal charges, but I'm going to mention them because they're important in each step. So in this case, the positive formal charge here is good because if the positive charge is on this atom, it's going to allow for the nucleophile to attack from this side much better. So in our case, the nucleophile is going to be our methanol. So let's draw out the methanol. So then the oxygen of the methanol is going to attack from the backside, or from the back, and then it's going to create this intermediate. What I like to personally do is whenever we have two groups on a central main carbon, I like to put the new group that we added towards the right and the older group on the left. So what I mean by that is once we attack it, we're going to have our same parent chain, but then our new group, which is the methanol, is going to be attached to the right side. So it's going to be right here. And then from here, we're going to have our OH, our OH right there as well. And then our OH is going to have no formal charge, and then our methoxide, or our methanol attached, is going to have a positive formal charge. Once that happens, we have to protonate and deprotonate. The reason for this is that in our final product, we know that we have two methoxy groups on it. We're not going to want to have this positive charge on this methoxy, and we're going to want to make this a good leaving group. So what can deprotonate and protonate? Well, from our reagents, we could use either H3O+ or water, so we'll be using both of them in this case. Our H3O+ is going to actually protonate this hydroxide right here, and then our water is going to deprotonate our methanol on the right. Once that happens, our intermediate is going to look like this. There's going to be a positive formal charge on the water, which makes that a good leaving group. And once we get to this step, this is called the halfway point, or we call this the hemi-acetal. Hemi meaning half, so it's half of it is an acetal while the other half isn't. And in this step, it's going to be a little different than what you've seen so far. We're going to kick out the leaving group, and in order to do this, we're going to have one of the lone pairs drop down, and then that will kick out the leaving group of water. That will then look like this. We're going to regenerate a double bond. We're going to have our methoxy on it, and this is also going to be positively formal charged. That's going to be good because once the second methanol attacks, it'll be better for that nucleophile as well. So, like I just mentioned, we're going to have our second nucleophile attack, which is going to be our methanol. So in this case, for this reaction, we're going to have two nucleophile attacks. And that's just one thing to remember. It's not like pad where you have to memorize each step or like know what happens each step. As long as you know that there are two nucleophilic additions that occur, that's basically all you have to know. And everything else you can just figure out, like what needs to get protonated, what needs to leave, what needs to get deprotonated, etc. So from here, we're going to attack the bottom. We're going to kick this up. We're going to have two substituents. Once again, we're going to have the new group on the right, and then our old group will be on the left. Our group on the left is going to have no formal charge at all, but then our group on the right is going to have a positive formal charge. From there, we're only one step away from basically having our original molecule, which is going to be two methoxy groups on each side. But the only difference is the right one, which is a methanol, has a hydrogen still on it. We want to abstract that hydrogen, getting rid of the positive formal charge. In order to do that, we're going to have more water molecules within our solution, so we can deprotonate using that. So we're going to have an OH2. That's going to deprotonate this hydrogen, giving us our final product and our major product, which is going to be our acetal. It's going to have two methoxy groups coming out from each ends. And then if you want, you could also write the water because we created water in the last step again as well. So this is going to be our major product of our acetal formation. And here was the mechanism behind it as well. I hope you guys enjoyed this video. I think that this reaction is very fun. It's not too hard. It just requires a little bit of practice. You can use pad if you want. You don't have to use it if you don't want. That's completely up to you. Thank you guys so much for watching, and I'll see you guys next time. Bye-bye.